So what we'll be talking about today is a bit of an overview of our outlook for 2025 here at Frost & Sullivan within our chemicals and materials team. So before we talk about anything specific, let me just introduce myself and my colleagues here. I'm Brian Balmer. I'm practice area leader for chemicals and materials overall. Been with Frost & Sullivan for over 20 years now, based in Oxford in the UK. So I have bit of a holistic overview of what's going on, hopefully, by speaking to all of my analysts. I'll be kind of moderating today's session. I'll go through some introductory slides initially, before I hand over to my colleagues who'll be taking through the detail of what we'll be talking about today. So to introduce my colleagues one by one, Christina Thomas is our sector leader for materials. She's based in India, been with the company for over 5 years now, and is our expert on a couple of specific areas. So actually, our whole team, because the chemical industry is so diverse, tend to have areas of specialisms here, there, and wherever they happen to have done research. So Christina leads our research on areas like lubricants. It is also one of our sort of experts on how digital technologies are affecting the chemical industry today. Sundarya Govashankar, our senior industry analyst for chemicals. Again, based in India. She's been with Frost & Sullivan almost as long as I have now. And again, her areas of expertise include general chemical industry trends, how mega trends are affecting the industry, and also certain specific industry sectors, such as coatings, for example. And Leo, finally, who's based in Buenos Aires in Argentina. He's our go-to expert on a couple of specific areas, one of which is sustainability, but also on specific product areas like construction materials as part of our wider chemicals and materials offering. So that's us as a team. As I said, I'll just start with a bit of an overview of the sort of mega trends that we see affecting the chemical industry today and how we've used those to identify some more specific growth opportunities for chemical companies in 2025. And then whenever I stop talking, I'll hand over to my three colleagues who will look at some specific opportunities that we see being created from those. And hopefully at the end, we'll have time for a few questions from the audience and before we wrap up on the hour at the end of this session. So before we go on to the details of what we'll be presenting today, I wanted to just show again the structure of our team. This is our chemicals, materials, and nutrition practice overall. Wanted to show it again here. I'm sure a lot of you on the call will already know who we are and how we are structured as a team. But this is also going to be an important part of how we structure the topics that we will be talking about today. So that's why I wanted to put it back up again. And just again, to clarify, we will be focusing today on what we would call the sort of chemicals and materials programs within our team. We won't be talking about nutrition and wellness products, but we will be doing our next briefing specifically on that area. So we'll be hosting that in Q2. So if that's a market that you are active in, then do look out for announcements coming up soon about that one. But before we go into any details of the outlook, I thought it would be worth reflecting on some of the reasons why we chose this structure for our team, because that in itself is also pertinent for today's discussion. And one of the reasons why we chose the structure that we have is because of the parallels that we see with how many of the major chemical companies also structure their businesses. And Arkema is a good example. Arkema is clearly basing its strategy around the areas that we here in Frost & Sullivan cover in our Polymers and Composites program, which is advanced materials for Arkema, and our CASE program, where we cover both coatings and adhesives. And Arkema have decided that there are other businesses, which they've grouped loosely into a division called Intermediates, would mostly map onto our chemicals program. And whilst these are not clearly part of Arkema's vision for the future, it's still an important program area for us. And of course, the divestment of those businesses has provided a great opportunity for other companies, such as some of the examples you've seen listed on there, for other companies to grow in areas where they see themselves being able to nurture further growth for those businesses. And as we will see in the coming slides, when we looked at all the trends we had identified across the chemical industry, simply competitive change was a major theme. So we'll come on to that in a bit more detail in a few minutes. So just reflecting on where the industry is today overall, it has been a tough couple of years for the chemical industry. Raw materials costs and squeezing margins, and growing production capacities in some parts of the world, in some cases producing overcapacity and increasing competitiveness in the market as well. Meanwhile, the industry continues to have something of a negative image amongst some sectors of society, despite the advances that we do see in improving the industry's environmental health and safety performance. But despite all of these challenges, we do still see growth for the industry, and you can just see on the chart here where we predict the industry's revenues going towards 2030 as the end of this decade. So what do we think will sustain that growth into the future now? Well, when we refer here in the title to cutting edge technology, we mean emerging and recently developed technological innovations that could offer significant advantages over existing solutions in the chemicals and materials industry. Now, these technologies include artificial intelligence-driven process optimization, digital twins for sustainable plant operations, advanced recycling technologies, bio-based raw materials, etc. Now, remember, Frost & Sullivan exists to help our clients grow. That's why I put the little graphic in the left-hand side of the slide here. And this concept of the industry's so-called transformational sustainable growth describes a business approach that simultaneously will deliver economic value whilst also creating positive environmental impact through reduced emissions, improved energy efficiency, waste minimization, etc. This dual focus on technological advancement and sustainability is one that we see in other related industries too, and it does represent a fairly fundamental shift from more traditional growth models in the chemical industry. So on to the actual topics we will be talking about today. What we'll be covering is based on the 2025 outlooks that we have published. And we have done one for each of the three program areas we're talking about today. So chemicals, polymers and composites, case and construction. And so I'll use this slide and the two following it just to show what we covered in each of those three outlooks. You'll see here in this graphic the same thing that you'll see on the following two slides as well. It's actually very similar to the model that we used a year ago as well. Then too, when we looked at all of the 10 specific trends or growth opportunities, as we call them, that we'd identified in the outlook, they all mapped onto a Venn diagram that had three overarching megatrends. Looking at what we'd written this year, we saw that a bit of a subtle change in nomenclature was needed. So sustainable and digital are the same as they were a year ago. But the third bubble here this time encompasses the trends that I was talking about earlier on, which is really, in a very general sense, competitive change. We are seeing a lot of trends that at their core represent an increasing competitiveness in the industry. So what we'll do in today's presentation is to talk about some of these specific growth opportunities, the things you see listed down the left and right-hand side of this slide, but we'll do so by consolidating them into a discussion of the megatrends. So we'll start by looking at digital trends across all three program areas, and then etc. for sustainability, and then we'll finish by looking at some of the other competitive opportunities across the 3 program areas as well. So that's it for chemicals. If we just look briefly then at we did in our polymers and composites outlook, and when I take a step back and look at all the opportunities that did make it into our top 10 in this particular area, what we saw was that many of them were simply opportunities to meet evolving needs of customer markets. There's a lot evolving in many of the end markets in which polymers are used. So for us, that is the biggest competitive opportunity this year, just to evolve with your customers. So that will be our focus when we come to talk about that particular bubble competitive trends in polymers and composites. And lastly then, for our case and construction materials program, perhaps where we've seen the biggest change in what's happening here is in the digital space. Christina has been working on a Frost Radar, which is our competitive benchmarking reports. And this one was to look at digital transformation trends in coating companies. And we've seen a real acceleration in what's happening there in the past few months. So that'll be, I think, an interesting area to look at today. So without any further ado, let's get into the details. You will see on the following slides a little icon in the top right corner, just as a reminder of where we are in the story. So as I said, we'll begin with the digital theme and starting with the chemicals program, and we'll take it from there. So the first of my colleagues that I will hand over to is Christina. So Christina, over to you.
Thanks, Brian. So as Brian mentioned, we have been looking at our outlooks this year based on 3 main mega trends. So first being digitalization or digital transformation. So this slide and following 2 slides, I'd be talking more about how digitalization has played out or is going to affect the 3 programs, starting with the chemicals program over here. Overall, this one's talking about AI, artificial intelligence for material design. So with the aggressive development of AI in various fields, the process of material design is bound to experience significant transformation during this year. So in the diagram given over here, you can see that I've listed out a few of the major factors associated with AI that is utilized in material design. And you can also see those grayed out dotted lines connecting all these factors. So essentially, all these are interlinked in one way or the other. So starting with Gen AI tools like ChatGPT and others have already penetrated the material design arena ever since the ChatGPT became so prominent and followed. So this is proven to considerably shorten the time taken by researchers to move from concept design to actual project execution. And the more familiar they get with these tools, the faster this process is turning out to be. So Gen AI is seen as a great tool for reverse engineering, simultaneous project optimization at different levels, and leveraging cross-disciplinary expertise by a single person, for that matter. So when earlier the research process needed multidisciplinary skills from different people, and you needed to bring about these skills together, collaborate with people around. But Gen AI has already kind of eliminated to a great extent of being in physical contact or constant contact with different experts, but a single person can do a lot of work in this regard. While these established or open source platforms of Gen AI that we all have access to are already being utilized, now companies are developing specific Gen AI tools for material design in addition to this. So Microsoft's MasterGen and MasterSim are 2 great examples here, and also Google's DeepMind's Norm is another deep learning platform that is used, which are at the forefront of such offerings. While MasterGen and MasterSim work in tandem to give a list of candidate materials and predict their stability and feasibility for real-world application, GNOME uses deep learning to predict the stability of new materials. And on top of that, Google very recently announced the launch of its AI co-scientist system just last week, if I'm not wrong. This is built with Gemini 2.0 to further aid scientists in this regard. So we are expecting penetration and utilization of more Gen AI systems for material design during this year and years coming forth. So then with Gen AI comes machine learning. As I mentioned, deep learning tools like GNOME is already being adopted. And along with that, machine learning is being integrated into AI tools for material design to help materials and chemical companies to innovate by accelerating R&D processes. In addition to Google's GNOME, the platform Alchemite from a company called Intelligence is another example. So this platform is designed for faster learning, fewer number of experiments done, and better results. Then coming to property prediction, Gen AI tools and VML deep learning platforms together help in predicting material properties with much greater accuracy in a significantly shorter time than traditional processes. And companies like BASF and Evonik and all have implemented AI with this as one of the key focus areas. And so when you look at sustainability, sustainability is the core for all material development and design, in most of the cases, at least in the chemicals and materials industry. And AI algorithms are now being integrated into various experiments to find means to enhance sustainability rating of products and solutions developed. And finally, collaboration is a key in any integration of digital tools in the chemicals materials industry. So, for example, the specialty chemicals company Evonik collaborates with IBM Research Europe and MIT IBM Watson AI Lab to explore AI applications in material design. Their joint efforts focus on predicting and refining polymer properties, significantly reducing the time required for material discovery from years to months. So similarly, Sekisui is working with Hitachi to use the latter's materials informatics platform in material development. So we will see more such collaborations, and a lot of companies like Intelligence are already working with multiple chemical companies to bring about the utilization of AI in material design. So overall, this is going to have a major impact in the way research and development is done in the chemicals and materials industry in 2025 and beyond. Brian, can we move to the next slide?
There we go.
So that was about the chemicals program. Now, coming on to the polymers program, one of the major primary development in the polymer industry, owing to digitalization, is the penetration of additive manufacturing in end-use applications. So, which has development to the which has led to the development of a lot of tailored polymeric products for various printer types that are used for 3D printing. This industry is set to show further growth over this and the coming years with advancements in printing technology. The list on the left-hand side of the slide that you can see highlights the main growth strategies that stakeholders should adopt to tap the opportunities from this trend. The first one, that is industrial production focus. So while prototyping remains the most widely used application of 3D printing in every end industry as of now, taking the next step to graduate or expand into industrial production will open more avenues for further market penetration here. So that brings down to the second point, which is mass customization. So the best route in this regard to expand industrial production would be focusing on mass customization than mass production, because 3D printing has a niche in this aspect as compared to traditional manufacturing methods. Recent developments in additive manufacturing materials and technologies, such as dual cure and multi-nozzle printers, dual cure resins, essentially, and multi-nozzle printers, are steps in the direction of additive manufacturing becoming a more mainstream manufacturing option using customized designs. Third one is invest in service bureaus, so third-party service bureaus. So 3D printing will lower the barriers for entry into highly commercialized large volume markets. For example, if an investor in footwear or home decor does not want to invest in a manufacturing facility, they can potentially use a service bureau to cater to the localized demand volumes. So this will not have a lot of capital investment required in machinery, and the investment in service bureaus essentially gives material and technology manufacturers a unique view on the possibility and limitations of 3D printing simultaneously in production and design. So again, manufacturers will be able to create innovative formulations for novel 3D printing technologies if they utilize or leverage third-party service bureaus for more industrial production. Investing in collaboration with different stakeholders is pretty self-explanatory. So like stakeholders like end product manufacturers, material manufacturers, printer manufacturers, and design software developments will all be very important as a collaboration partner. Material manufacturers require strategic partnerships with multiple printer manufacturers rather than optimizing materials for a single printer. So that would be one of a key aspect to keep in mind while you're venturing into 3D printing material development. And finally, optimization for maintenance and repair. So improving standardization and establishing testing methods for 3D printed products will drive adoption in MRO applications. Additionally, the need for an on-demand manufacturing supply chain to procure spares and repair panels in automotive, aerospace, and other industrial applications also will drive growth. So these strategies could be great opportunities to expand market presence in the 3D printing materials market. Can we move to the next slide, Brian? Yeah. Finally, the third one, which is the case and construction industry. So here specifically, we have picked out coatings, digitalization coatings. As Brian mentioned, I'm currently working on a competitor benchmarking analysis of the digitalization trends in the coatings industry. And based on my research, what we find is that a lot of new developments have come up in the coatings industry over the past year than what had been happening for a few years before that. Just give me a moment. I need to cough. Sorry about that. So listed over here are 8 of those key trends that I've identified through my research. And with coatings in mind, the major one is investment in digital technology to utilize or improve color matching, color precision. So coating companies overall, almost all paints and coatings companies, leading ones, have implemented such digital technologies, be it for color optimization while production, or color selection, or color matching services for customers. So leading companies have invested in various tools for color visualization, both app-based and web-based, and have integrated AI for color matching. So companies like Sherwin-Williams, AkzoNobel, Nippon are few examples over here that have such visualization and AI integrated tools available. Digital platforms are being widely used for marketing purposes, both through social media and e-commerce platforms. Digital tech support is now in high penetration in this industry, where companies utilize a variety of technologies to support customers' operations, including audits, project support and updates, training and provision of training materials. So all these, so various digital platforms and digital tools are being used to enhance the technical support offered to customers in the coating space. Speaking of training, augmented reality or virtual reality are being greatly adopted by large paints and coatings companies in training activities. A leader in this regard is AkzoNobel, as an example of which is its partnership with American Airlines to deliver a new way of training apprentice painters and upskilling existing teams through the use of virtual reality technology. Remote maintenance, especially for customers in the marine and offshore applications, is another notable offering from coating companies using digital technologies. So here, an example is Jotun's hull performance solutions, which is a great example. It combines its digital capabilities, remotely operated vehicle inspections, and analytical and technical expertise to help operators keep fuel, inspection, and cleaning costs under control. So it uses a suite of sensors and other digital technologies, including AI, to enable this. Project planning tools. So various tools like project design tools and paint calculators and are also being offered by coating companies to their customers. So PPG's tool called Advance is a very relevant example in this regard. It helps plan the projects at the customer's end through various steps. Digital tools also being developed or employed in this industry for ordering and fulfillment. Supply chain optimization is greatly being evaluated, and technologies are being developed and employed in this regard as well. And finally, AI and machine learning are greatly being adopted in multiple operations, including color design, plant operations, supply chain, services, marketing. So all other aspects that I've already discussed over here, AI and ML and deep learning, etc., are gaining more penetration, more utilization for all these activities. This was an overview of the digitalization trends in the three programs, at least the key highlights.
No, thank you, Christina, for that. We're already halfway through the time we've allocated for the briefing, so we will speed up a little bit now. What I would say is that we can make these slides available to anyone after the presentation, and if you want to know more detail about the themes we're talking about today, for those of you who are subscribing clients, you can get our outlooks from frost.com. Anyone else, if you just get in touch with us, we might be able to send you some extracts from those outlooks as well. So do get in touch if you want to see more. But on that note, Sundarya, I'll hand over to you next to start talking about the big sustainability themes that we see in chemicals.
Sure, Brian. So when we talk about sustainability in the chemical industry, I think biorefineries are the most important ones that are presenting a lot of opportunities. We have these first generation, second generation, third generation feedstocks. First generation have always faced a lot of criticism as it competes with food and feed. So there has been a significant transition to second generation feedstock. Primarily agricultural residues, forestry residues, and wastes. I think waste management is one of the key topics across several industries. So industrial waste, urban solid waste, municipal waste, domestic waste are all being considered as feedstock to produce higher value chemicals. So the concept of biorefinery is gaining momentum, both among new companies that are trying to develop high value chemicals, fuels for based on these feedstock. And we also have these traditional chemical companies looking at biorefineries, establishing their own biorefineries for enhancing their sustainability footprint. And industry is definitely seeking to switch to sustainable feedstock. So there is going to be demand. However, it is about looking at how the industry is growing. The industry is still struggling with dealing with these raw materials in terms of sourcing, pricing, and everything. But technically, there has been successful commercialization of some conversion of some of these waste and agricultural or forestry residue-based feedstocks into high value chemicals. Now, it is not just about the type of feedstock that is used. When a company is trying to use a sustainable feedstock to produce sustainable chemicals, the process needs to be really sustainable. So it is about operating temperature, pressure, use of chemicals. There are so many things that are attached to it. So that is how the industry is evolving. And there has been a lot of funding. Europe and the US has seen significant grants and subsidies, incentives towards these new biorefineries. So this is definitely an important opportunity that the market will be going in. And the third generation feedstock with that is considering microorganisms, microalgae, and other marine biomass to produce chemicals is also an important area. So, and we've also seen where carbon dioxide, waste-based, one of the waste-based feedstocks, carbon dioxide, to be converted into chemicals. Here, this basically, it is important to see when the carbon capture, when the CO2 is coming from CCUS facilities, we need to determine how economical the entire process is going to be. And since the CCUS economy itself is developing, we see that taking a little bit more time than how the others will probably gain traction. So on the right-hand side of the slide is what we have around how the circular economy is being established. So we have the CCUS facilities that actually presents a lot of opportunity for the chemicals and materials as a whole, not just sustainable chemicals, but there is a lot of opportunities for membranes, ionic liquids, solvents that this entire economy is demanding. But if the CO2 obtained from such facilities can be used to produce higher value chemicals that again goes into the industry, then that establishes a good circularity within the space. So not just CCUS, but we will be discussing later on about how similar economies like green hydrogen, CCUS, they all would prefer to use sustainable chemicals, but that is currently not really possible, considering that these industries will have to reach some level of scale in order to be able to do that. So biorefineries are definitely an important concept to be that the chemical industry will be looking into.
Next thing we wanted to talk about was again on the sustainability theme, this time focused specifically on polymers and composites. And, arguably one of the biggest challenges for the chemical industry overall is to make plastic more sustainable. The big question for some time has been whether bio-based or recyclate-based offers the best solution for the plastic industry. But that simple choice is becoming more complex as the amount of investment going into chemical recycling, not just mechanical recycling, is really taking off at the minute. Every day we're seeing new announcements in this area, and some examples I saw just in the past week SK Chemicals confirming its plans for a recycling innovation center at its plant in Ulsan in Korea, with the focus will be on chemical recycling of PET. Meanwhile, we've also just seen an announcement from Avantium and Amcor, and packaging company, announcing a partnership to drive the use of the bio-based plastic PEF in packaging. And obviously PET is the main material against which PEF would compete. So interesting contrasts there. But on that note, I'll hand over to Leo to take you through some predictions of our own in this area.
Thank you, Brian. For the record, I want to thank also Aditya Krishnan, which is a member of our team, for his help in these slides. In this slide and in these charts that we are showing you, we wanted to give a clearer view on what's happening on some aspects of sustainability of these materials, particularly because there is a lot of work to be done. As we can see here in the first chart to the left, only around 9% of all plastics that are being produced are being recycled, and that the vast majority of those are being mechanically recycled, which is the largest solution that's being implemented. With a tiny share, you will see that there's a black line there at the bottom that is being chemically recycled. We have two forecasts for that. You will see the first forecast on the dark blue and light blue chart, and the second forecast for chemical recycling on the...
Can you see my mouse on the screen?
We can see your mouse. The second to the left, because we did two different studies with two different optics, and fortunately we achieved very aligned results. So you can see volumes to 2030, those are in kilotons per annum of input capacity. So the forecast in dark blue was done on company announcements. And you will see that there is a large growth, but it's still a pretty tiny share of all of the recycling that's being done. And this forecast on dark blue color was done based on the company's announcements from companies, which given what I am going to talk about in a couple of minutes, when it comes to geopolitics, the pressure on sustainability, and larger amounts of fossil feedstocks could reduce the need for recycling. So those are the announcements. We'll see what happens in the next few years. The overview picture, the broad picture of the market is that gasification and pyrolysis take the largest part, but we have identified a very, very, very interesting business ecosystem, a business ecosystem composed of dozens and dozens of different technologies and startups that are doing things very interesting to chemical recycling. When it comes to chemical recycling, we are talking about companies that will give you a couple of shipping containers that you can take to your landfill, and those shipping containers do microwave-induced pyrolysis, and you can do everything there. You do the drying of material, the mechanical recycling, the chemical recycling. You get the output right there next to where the waste is. And we are seeing also some very interesting stuff with companies that are designing enzymes for textile recycling using AI. So again, the AI thing appears again. So very interesting stuff in there happening. Coming to the chart in orange and light blue, the third one from the left comes from our last study on polymers. We found some very interesting CAGR rates for recycled polymers in electrical and electronic equipment. You know that electronic and electric equipment represents a very large part of the waste that we generate every year. So we have some interesting rates in there. You will find them on the notes. And when we try to foresee where the chemical industry will take its raw materials from in 2030, we see some interesting growing shares of recyclates, bio-based raw materials, and raw materials coming from carbon capture on the way to 2030. So what will happen in 2025 is a little tiny steps of this that is going on its way towards 2030. Can we go to the next one, Brian, please?
Sure.
Yeah. So when it comes to sustainability in construction materials, we have identified all of this because we are actually doing a benchmark of sustainability strategies across all the major global construction materials manufacturing companies. So in a couple of weeks, we'll have a radar on that. So starting from the left, we see that some leading global construction materials companies are putting their eyes on wood frame and steel frame in markets that are not very mature in those technologies. So that's very interesting. And when it comes to mass timber is going very fast, but we still see it very restricted to very mature markets. Of course, when you look at stuff like steel frame, it's very interesting because you can pre-build some parts, you can build it fast, you take it to the building site, it can be very thermal efficient, you can recover materials, and along the life cycle, when you do an LCA, you get reduced emissions when compared to more traditional building systems. Some of the things that we will see in 2025 are bio-based raw materials growing their share in the market. So we have new portfolio options in there. Examples, BASF is doing some polyurethanes with biomass balanced raw materials. Covestro is doing something very similar with its polyurethane insulation boards that contains waste from plants. CRH is doing some biobinders for asphalt using also plant-based materials. Something very interesting that we are seeing when it comes to how construction materials can deal with adaptation to climate change and resilience, because that's the question that we would like to, that needs to be answered here, is how materials can improve the resilience of the built environment. We are seeing the industry waking up to that particular variable. For example, in the last couple of weeks, LEED announced that its version 5 will require resilient assessments. So that's I see a sign of maturity there. Then something that has been going on for decades, but you could say that there is a lot of improvement that needs to be done in that area, has to do with how all the cities basically look like each other, particularly when it comes to high rises and premium residential, where you see lots of glass. When the window used to be a facade material, it used to be a window material, it turned out to be a whole facade material. And that requires lots of energy for heating, for cooling, lots of things to be there, to be done in there as well, because you end up depending on how efficient the glazing unit is to isolate that cold and that heat. Of course, I cannot leave it aside, AI and material science. We are not seeing construction materials designed from AI yet, but all the construction materials companies are increasingly looking into that, and AI, of course, is already impacting how the companies turn their processes into more efficient ones. And I don't need to go through again of of how AI is impacting the work environment. Finally, we see that the recovery of materials will keep increasing. We are talking about wind turbine blades into concrete, recycled glass into asphalt, plastics into bricks. That kind of stuff will keep going on, and we see that recovery programs are becoming more popular into construction material companies. So they are trying to sell their product, but they are also trying to find the way of recovering it. We are talking about here of glass insulation, glazing units. So companies that are trying to recover those to recycle them and get them back into the circuit, into the loop.
So that's sustainability. We're going to move on now and talk a little bit about competitive trends in the industry and what we see going on there, whether it be geopolitical or competitive M&A trends in the chemical industry itself. We'll start with the chemical industry overall. And Leo, again, this is a bit of a passion of yours, so back to you.
Things have been changing very fast in the last couple of weeks since we wrote these outlooks in December. So I had to throw everything away and make it like a brand new. So in 2025, what are the three main factors that we're going to have to look into? We are talking about geopolitical volatility. This is Trump 2.0. This is Middle East. This is we are on the third year of Russia's invasion to Ukraine. We are talking about China's dominance on supply chains. The second factor has to be with environmental changes. Trump is slashing regulations. He's going drill, baby, drill. You have heard about that. And the European Union, as a response, is simplifying environmental regulation, sort of trying to stay competitive. And China is like a sort of gray box, and it has leveraged for decades on labor and environmental policies and government intervention. So that's a sort of panorama there. And again, we are talking about tech disruption as a third relevant factor, where we have AI permeating everything. Now, what are the conditions that the chemical companies are going after? They are going after energy and raw materials, so that needs to be stable. They need regulation and policies also to be supportive and stable. They need growing markets, and chemical companies also need innovation through research and development and digitalization. So what are we seeing on those aspects and how those interlink to each other? Trump wants to energy security. He's going to drill aggressively and push for supply chain reshoring. So the consequence of this is that if he's successful, that's going to bring down energy costs. But this also raises some questions about how the companies are going to drive forward their green portfolios. So if you have fossil-based energy and fossil-based chemical feedstocks flooding the market, what's the motivation for chemical companies to drive forward their green portfolios? When it comes to policies and regulation, we see that the US is going for a free market inside its borders, but then it's building walls to the rest of the world by using tariffs. And again, the European Union is doing some changes on how the business works on its territory to improve business competitiveness. The United States is going hard on Chinese companies with tariffs, and it's going also against the World Trade Union, the World Trade Organization. China is answering with the same strategy with some tariffs that are also impacting rare earth materials, but that's on the export restrictions side of the equation. And Southeast Asia is receiving some investments that are leaving China. When it comes to research and development, we see that United States is slashing federal funding, so that's drives us to look at what the states are going to, the individual states are going to do when it comes to funding, because the Department of Energy, the EPA, the Department of Defense are going to cut on those sustainability-related investments. And that could be an opportunity for Europe to take up those startups into their territory and fund all of the little companies that will be flying away from the United States. Finally, we have this thing going on Ukraine and the Middle East. So if Trump Factor 2.0 brings peace, that could stabilize the region, bring down prices, that would benefit European manufacturers. And if the IMEC corridor also comes into shape in 2025 forward, that will also stabilize the region and will bring some security to supply chains and into that region. So in short, I believe that the word for 2025 from the chemical companies' standpoint is pragmatism, because lots of things are changing very fast, and that's basically, it's going to be a year of transition. So that's what we see basically on
and a
this.
lot going on as well, which is why we're running a bit short of time now. There's a lot to talk about. Yeah. So Christina, Sundarya, I'm afraid you've got 2 minutes per slide maximum just to do a quick summary on the last 2 points you wanted to cover. So competitive trends in polymers and composites. If you wanted to just talk very quickly about this, Sundarya, and then we'll move on to the last slide as well.
Sure, right. So here competitiveness is more around the new emerging markets that you're investing in. Like I think Brian introduced this point, was talking about this point while describing the overlapping circles, Venn diagram. So this is about how green hydrogen is offering a lot of opportunities for chemicals and materials like, basically polymers and composites, not just the epoxy resins and the composites that are used in pressure vessels, but also a lot of simulation, winding, and advanced structural simulation. There is going to be an increasing role of AI and automation that Christina had talked about in the beginning. And the next important industry will be the modern construction, where these polymers and composites are going to be increasingly helping enhance the sustainability of buildings by enhancing the thermal, by making thermal enhancements to the building, and also increasing the resilience by the use of plastic based bricks or plastic windows, those type of things, weather strips for better sustainability, weather strips, insulation systems and all, continuous insulation systems. And we are moving, the world is moving more into active lifestyle with fitness and focus on running and everything, active lifestyle. So there is going to be a lot of need for smart polymers that are breathable, that could basically, there would be a lot of scope for 3D printable polymers, polymer grades. And then talking about healthcare, there is an increasing need towards less invasive surgical tools and skin safe polymers. So there is going to be a lot of opportunities for that type of polymer. So most of these competitive aspects will be aligned to the changing end markets and the dynamics within different and customer segments.
Yeah, thanks, Sundarya. Yeah, definitely. They all offer opportunities for companies to differentiate themselves, polymer companies, and to gain a competitive edge, which is the aim of today's discussion. So then, last but not least, where do we see the sort of competitive landscape in case and construction materials?
So, the overall competitive landscape in the case and construction industry has been experiencing a very notable shift over the past few years. And a major contributing factor is the changing raw material landscape here. Over the past few years, the raw material landscape has been undergoing a gradual but definite shift in the way the raw materials are used, the type of raw materials procured, etc. Major ones of the factors that affect the shift in raw material landscape is listed in the graphic in the top left section of the slide. To a considerable extent, the design trends in some of the end industries, such as construction, automotive, aerospace, and other general industrial applications, have influenced the development and also commercialization of very advanced or different raw materials, more sustainable ones, all based on the end customer requirements. In addition, multiple regulations and policies implemented in different countries and regions, along with various sustainable initiatives by the chemicals and materials companies themselves and also their customers, are greatly contributing to this evolution. So while factors like decarbonization, bio-based material usage, increasing the recycled content in raw materials used, etc., are factors that come out of the sustainability trend. While, as Leo discussed before, certain geopolitics factors like the new government in the US and the changes in policies, both affecting international relationships as well as sustainability drive, are all contributing to the change in the landscape. So the graphic in the bottom left section of this slide highlights some of the notable strategies that are being adopted by the chemical companies or chemicals and materials companies, or should be adopted by the different stakeholders in the value chain to address some of the challenges and unmet needs in the end markets. So we have already begun seeing an increase in vertical integration strategies adopted by the case companies to gain manufacturing abilities of key raw materials. We've seen that in the coatings and adhesive sealants industry, and in addition, with changing geopolitical scenario, the industry will witness more nearshoring or reshoring strategies to optimize supply chains. And another key strategy that needs to be widely adopted is tying up with more than one supplier for raw materials in each of the different regions that a company operates. Digitalization, as I discussed earlier, is also being greatly adopted to optimize supply chains and enable dynamic risk management in this regard. So for all these, collaboration amongst stakeholders in the supply chain continues to be very important in this industry. And with these trends in mind, we will witness more change in the competitive landscape in the overall case and construction industry. And I'll briefly hand over back to Soundria to discuss specific examples in the architectural coatings market.
30-second summary, Soundria, please.
Yeah.
So I'll just like to highlight that we just completed an analysis on the architectural coatings market, and we've found that this market has so much of dynamics with a lot of companies, in fact, the top companies making strategic moves by divesting their big markets like the US decorative market from PPG. PPG divested its architectural coatings market in the US, which is really big. And Sherwin-Williams divested its Chinese business in 2023. And within the Indian market, you see a lot of newcomers, new entrants, and majors like AkzoNobel exiting the market. So that there is a whole lot of dynamics that we've covered in the study, but because of we're running out of time, I'd like to stop it here. More on the report.
Great, thanks, Soundria. But as you said, if anyone wants to know more, they can look at the decorative paint study that we'll be publishing very soon. So yeah, thanks everyone for today. I'll only take 1 minute maximum just to reflect on what I sort of see as the kind of the key conclusions here. And I think AI was a theme running through everything. For me, there's two sort of key takeaways there. One is the fact that the systems are referred to as, for example, co-pilot and co-scientist. So when I speak to people in other industries as well, they say, this will not take over the jobs. They are your co-pilots. They help you. They don't take over what you're going to do. And we're actually just starting to see some really interesting results coming out from the use of AI in related industries as well. Really interesting one last week about a researcher who's looking at how microbes develop antibiotic resistance. He spent years researching this. He just thought he'll ask AI the question, how do you think bugs develop antibiotic resistance? And in 2 days, it had come up with the same hypothesis that he'd been developing for 15 years. So yeah, interesting results, that. The other one then is around the whole competitive changes and how that's being affected by sustainability and just, the competitive changes in the chemical industry. We are seeing new companies become suppliers of chemicals, which is something that hasn't happened in a long time. So forestry companies like UPM and Stora Enso increasingly also being suppliers of chemicals, whilst at the same time the traditional chemical companies are diversifying themselves and maybe offering more digital technologies to complement their physical chemicals as well. And again, that's not something that historically had happened so much. So a lot of interesting stuff going on. I will stop talking there. Thank you very much, everyone, for your time. And I'll just hand back to Julieta to wrap up for us. And thank you for your time from my side, everyone.